Hi everyone and welcome to today's Kitchen Sessions live lecture, and it's called Hidden Figures, a Movie Star and the Women of Bletchley Park, the Hidden Histories Behind Our Mobile Phone Apps. And it's going to be delivered by Dr. Helen Southall, Senior Lecturer in the Department of Computer Science, Electronics and Electrical Engineering here at the University of Chester. My name's Anna, I'm an HE advisor here at the university. I'm joined by my colleagues Grace and Vicky, who are behind the scenes helping out with your questions today. So just to start by reassuring everyone watching that your video and audio aren't going to be shared during the course of the session. Shortly, I'll hand over to Helen. Just to tell you first of all that if you want to participate by asking questions, you can use the chat function on the right-hand side of your screen. You can ask questions anonymously if you want to. You just need to tick the box to say you want to be anonymous. And you can also like other people's questions. If there's something that comes in that you also want to find out, then do give it a thumbs up. And at the end of the lecture, then Grace will be asking all your questions to Helen, and hopefully we can have a bit of debate at the end. So I think that's everything, and I'll pass you over to Helen now.
Okay, hello everyone. As I've just been introduced, my name's Helen Southall. I'm in the Department of Computer Science, Electronics and Electrical Engineering in the Faculty of Science and Engineering at the university. And I'm going to talk today about some lesser known stories behind the mobile phones that we all carry around with us. How did the mobile phones get to do the things that they do? What's the technology behind them? Where did it all come from? Okay, so why have I picked on mobile phones? What's interesting about them? What can we learn from them? Well, one of the reasons I picked on mobile phones was because of this statistic from the Ofcom technology tracker from last year. The question was asked of a representative sample of the whole UK population. Do you personally use a smartphone? And 82% of people answered yes, they did. Now that was for the whole population, including very young children and the over 90s. Now, if you actually narrow that down to 18 to 24-year-olds, then the 99% of people who answered yes. So that's basically saying that almost everybody between the ages of 16 and 24 uses a smartphone, or says they do. Now, this is a survey. Some people probably said they do when they don't. Other people are sharing their brothers or sisters or whatever. But basically, everybody uses smartphones. And as we all know, smartphones do an awful lot more than just making phone calls. One of the example that I've decided to pick on today is what we might do if we go to a new city and we need to find our way somewhere. Say you were coming to Chester for the first time to come to the university, and you'd arrived at the railway station and you wanted to know how to get to the university, and you decided to do the healthy thing and walk. So you ask your phone, how do I get to the University of Chester? You type in the University of Chester's address, you tell it where you are at the moment at Chester Station, and it puts the little dots on the screen and tells you which way to go in order to get to Chester Station. And it will give you a blob telling you where you are right at this precise moment, and it knows where you are and it can tell you how to get there. Now, that's pretty impressive for a little battery-powered gadget that you can hold in your hand. And so one of the things, well, the main thing I want to look at today really is how do we get to the point where 99% of 16 to 24-year-olds in this country are saying, yes, I've got a gadget that can do that. Because as I say, that's a pretty impressive trick for a little battery-powered gadget to achieve. So what is a smartphone? It's basically a small computer. It's a portable, programmable, general purpose electronic computer. Now, one of the things that it does is it communicates with other computers via radio waves in lots and lots of different ways. I mean, your smartphone doesn't just have one radio antenna, it has 3 or 4 or 5 of them built into the back of it. It's got antennas that talk to the cell phone network, enable you to actually make phone calls with it, send text messages, download data, all that kind of thing. It has an antenna which talks to the Wi-Fi network. If you're in a building or in a town square that's got Wi-Fi, then it's got a Wi-Fi antenna as well, so it's communicating with Wi-Fi by radio. And it's also got an antenna which can talk to other computers, other phones, other gadgets, the Internet of Things via Bluetooth, which again is radio communication. So your mobile phone is one of the things it is a computer. Another thing that is a very complicated and advanced radio transmitter and receiver. Now, as well as all that, it can work out where you are, because it can't tell you how to get to the station and how to get to the university unless it knows where you're starting from. And it can work out where you are using GPS data, which relies on satellites, which are many miles above us, orbiting the Earth. It also relies on digital maps, which it can download via cell phone networks or Wi-Fi. And it relies on routing algorithms, computer programs, which actually tell it, if the user says they're starting at the station, they want to go to the university, here's the roads, here's the possible routes, and the algorithm will work out which is the quickest or which is the best. Now, in this talk, we're going to look at some of the people behind the technologies that actually make this possible. They are just some of the people behind the technologies. None of these technologies were invented by one person. And I've deliberately picked on some people that might be less well known, because I think they need to be more well known. But I'm absolutely not suggesting they're the only people that were involved. And one of the things that's exciting about this is that there's opportunities for huge numbers of people to get involved in these developments. Okay, so I said first of all that your mobile phone is a programmable digital computer. Where did they come from? Well, computers are something that we just take for granted now, but even within my lifetime, that has not been the case. So my dad used to work at the BP Research Centre down in Sunbury in West London, and he was involved in fitting out one of the first buildings there, which contained a computer. And this computer had a building all to itself. It had its own air conditioning system. It had technicians who were on duty 24 hours a day to fix it when it went wrong, which it did frequently. And that was in probably the 1970s. It's not that long ago, really, in the big scheme of things. And certainly I never had a computer when I was aged 16 to 24, although I did use one or two, but I certainly didn't own one. So where did they actually come from? Well, the picture on the left is a picture of some of the women who worked at the Government Code and Cipher School, otherwise known as Station X or Bletchley Park, during World War II. And Bletchley Park is really, really significant in the story of computing, because it's where one of the first ever electronic programmable computers was built. There had been mechanical computers for many years before that, but this is one of the first electronic ones. And on the right, you can see a picture of one of the Colossus machines that was developed at Bletchley Park, which was, they were huge, they used enormous amounts of energy, and they required operators just to keep them doing anything. I need to quickly explain what Colossus actually did. Bletchley Park, as the name suggests, the Code and Cipher School, what they did there was they broke codes. This was during World War II. The German military and their allies were needing to send messages, orders and so on, and receive information about how things were going on their side. And the Allies, the British, US and so on, wanted to know what was being said, but naturally enough, the Germans did all of their signals in code. And so places like the Code and Cipher School, their job was to try and break that code and find out what was actually being said in the messages. Now, code breaking is a mixture of linguistics, inspired guesswork and mathematics, lots and lots of mathematics. And a lot of that mathematics is very repetitive. You're doing the same thing over and over again, particularly if you've got a lot of messages. And so these machines, like Colossus, their purpose was to do these repetitive sums as quickly as possible. And so many of these machines were built. They were developed by famous mathematicians like Alan Turing, but they were operated by an awful lot of people who we'll never know the names of. There were more than 10,000 people working at Bletchley Park towards the end of the war, and 3/4 of them were women. None of them were ever, well, certainly until the 1970s, they weren't able to say to anybody what it was they'd done at Bletchley Park. So Turing, when he left Bletchley, had to kind of reinvent an awful lot of the work that he'd done. The women who worked there were not able to apply for jobs and say, hey, I've worked with computers, because they weren't allowed to tell anybody what they'd done. And this is one of the things I find very fascinating about the history of places like Bletchley. So, OK, that's just a very tiny hint of some of the things that went on at Bletchley Park. It's a national heritage centre now. There's a museum there, and we're going to say a little bit more at the end, possibly, about that. The key thing here is, though, this is where computers have come from between 1940 and now. It's really not that long. It's 80 years, and yet we've gone from something as big as this, which really doesn't do that much in modern terms, to something we can put in our pockets. OK, so a different angle on how we get our mobile phones to work. Now, remember I said earlier on that mobile phones were really reliant on radio communication in all sorts of different ways, both for actually making phone calls and also for connecting to Wi-Fi or Bluetooth. Now, the image on the right, the diagram on the right, is part of a US patent from 1941. As you can see, the names on it are Hedy Keysler-Markey and George Antile. It's part of a much longer document, but basically what this document describes is a secret communication method, a radio communication method. So that should give you the hint where I'm going to with this. The idea was that they were suggesting that this method should be used to control torpedoes. So when a torpedo leaves a submarine, you want to control where it's going. You perhaps want to be able to change its course. And the problem with trying to control anything by radio is that if other people can intercept your radio transmission, they can find out what it says, they can maybe even jam it, they can stop it from reaching your torpedo in this case. So the idea of this system was that rather than always broadcasting on one frequency, it would change frequency at regular intervals. There was a timer in the transmitter in the submarine, a timer in the torpedo, and as they clicked on a second at a time, say, at every click it would change the transmitting frequency from the submarine. That would also change the receiving frequency in the torpedo. And that makes it much, much harder to intercept the message, because it's constantly going from one frequency to another. You've got to know when it's going to jump in order to be able to intercept the message. Also, it means it's easier to overcome just natural static, because it's unlikely to be over all of those frequencies. Now, as it happens, this particular system wasn't used in torpedoes. But in the end, it was one of the background ideas which was used for systems which are very widely used today, called spread spectrum radio communication, which use exactly that kind of idea, although not using the exact mechanism shown here. Now, what's that got to do with the rather fabulous looking woman on the left? Well, H.K. Markey, Hedvig Markey, and Hedy Lamarr are actually the same person. Hedy Lamarr was a famous film star in the 30s, 40s and 50s, but in her mobile home, her caravan, where she retired to in between takes, she didn't just have the usual array of makeup and dresses, she had her inventor's kit. She loved science, she loved technology, and she invented things for fun. And when she saw a problem that she felt needed solving, she would work on a solution. This particular solution she worked on with a friend of hers who was a composer called George Antile. Okay, so this has got us. This is one of the one of the places that Wi-Fi and cell phone communication and Bluetooth came from, because they all use a variation on the same idea of spread spectrum radio communication, which is really hard to say, but I'm sure much harder to do. Okay, so our final group of people then. We've now got a computer. We've got a way of communicating with that computer because we've got spread spectrum radio communication systems. And remember what we were asking our computer to do? The task we set it was to tell us how to get from Chester Station to the University of Chester. And one of the things that's absolutely essential for that is satellites. You have to have satellites for a global positioning system, which is what GPS stands for, is Global Positioning System. Basically, the satellites have a very accurate clock in them, and your phone picks up signals from hopefully 3 or 4 satellites that it can see from where you are, and it works out how far away those satellites must be based on how long the signal has taken to arrive from the satellite to the phone, and it then just complicated sum which tells it where it is relative to those satellites. We know exactly where the satellites are. If we know how far away they are, we can work out where our mobile phone is. And your phone does all that calculation in minute fractions of a second. So it's not just any old computer, it's a really powerful and fast computer. But going back to the satellites, how did they get up there in the first place? Well, part of the reason we have satellites orbiting the Earth is because of the space race in the 50s, 60s and 70s between the USA and what was then the USSR, the communist Russian empire, I guess. And this space race, one of the main things that it was about was trying to get a man on the moon, trying to actually get people, first of all, into orbit and then to land on the moon. It was a huge enterprise. Huge numbers of people were involved from actually a very wide range of backgrounds, which brings us to the hidden figures part of the title of this talk. Some of you may have seen a Hollywood movie called Hidden Figures, which was about 3 black female mathematicians who worked for NASA during the 1960s, and their job title was actually computer. Until the 1960s, a computer did not mean a box, a machine. It meant a person, somebody whose job was to do computations. And these 3 ladies, Mary Jackson, Catherine Johnson and Dorothy Vaughan, were computers who worked at NASA. So they were highly qualified, very good mathematicians who would be given computations to do, and that's what they did for a living, basically. Now, the film Hidden Figures is not a documentary. It's not absolutely 100% accurate on every point because they had to make it a story which would fit into an hour and a half of Hollywood movie. But the basics of the story are actually quite true, completely true. These 3 women did exist and they did do more or less the jobs they were described as doing. Mary Jackson was the first female aeronautical engineer at NASA. She actually qualified as an aeronautical engineer while she was there, and worked on the development of the space vehicles. Dorothy Vaughan was one of the first women to work with IBM computers at NASA, as well as being one of the first black female team leaders. And Catherine Johnson is particularly relevant for this story because she was a mathematician who worked a lot on guidance systems. So she did a lot of calculations to do with how to, first of all, get a man in a space vehicle into orbit and back again, and then later actually landing the first Apollo missions actually on the moon, finding your way 250,000 miles all the way to the moon and back again. A lot of that guidance was actually calculated by Catherine Johnson. And another side point, while we're just talking about NASA and the space race, I was listening to a podcast called 13 Minutes to the Moon about this last few days, and one of the points that was really made about that was that it was the first time you had to really get a very small computer and a very reliable computer was when they decided to send men to the moon. The computer had to operate reliably for over a week, and it had to be very small and very light. And as one of the guys on the podcast said, that was the first time people stopped boasting about how big their computers were and started instead to boast about how small they were. And that is part of what gets us our portable, powerful computers. They come from that lineage, if you like. Okay, so I've really just scratched the surface on all these stories. There's so much more you could tell on all of these, but just to wrap up then, we have in our hands, when we carry a smartphone, we've got a portable programmable electronic computer. We have a secure radio communication system, and we're reliant on satellite positioning and the product of the space race and the guidance systems and so on that went into that. They've all fed into what we have in our hands when we're trying to find our way from Chester Station to the University of Chester, say. Okay, so that's it from me now. That's my talk over, but I'd love to hear if you've got any questions about any of that, anything you'd like to hear any more about. Thank you.
Thank you, Helen. It's so good to find out so much about the thing that I rely on the most, which is my smartphone. I mean, I don't put it down, so it's really good to be able to dive into that a little bit more. We have had a couple of questions come through, so I'll just put those to you now.
Okay.
For anyone interested in what you've been talking about today in mobile phone technology, what courses can they study at Chester on that topic or to do with that?
Okay, well, practically any of our courses in the Department of the Computer Science side of Computer Science, Electronics and Electrical Engineering will cover some aspect of that. Our computer science course is a general computer science course, but it will include programming. It will include programming specifically for mobile devices. It will include software engineering and all of those sorts of things. We have a software engineering degree, which is specifically about developing software more for businesses, I guess, and that kind of thing. We have a cybersecurity degree, and as you could hear from what I was saying about the security aspect is never far from anything to do with computers, and you certainly wouldn't want people easily being able to listen to your phone call. I mean, there have been in the early days of mobile phones, that was a big problem, and it's a constant race between people who just want to use phones and people who've got nefarious reasons for wanting to know what's being said and what data's being passed. So cybersecurity is a big one as well. And of course, we also have a games course, and lots of people play games on their phones. So yeah, any of our courses really.
Brilliant, thank you very much. Somebody else has asked, it sounds like you're interested in history as well as technology. Do you manage to include this in your research or in your teaching?
Yes, certainly I do. My main area of research is what's called digital humanities, which is applying computer science to humanities subjects, in my case, particularly history. I'm currently doing some research projects with the Grosvenor Museum, and also working on a new project to do with a sustainability centre in Chester. And all of those things are about combining what you can learn about computers and what you can do with computers and actually applying them to things to do with history and society.
Brilliant, thank you very much. And we've just got one final question, and that is somebody saying, I want to do a degree in another subject, but maybe do a master's course afterwards to help with my employability. Are there any master's courses on computing that would take me if I don't have a computer science degree?
Yes, yeah, there definitely are. I mean, we've actually got 3 different MSc courses, one of which does assume that you've already done a BSc degree in computing, so that's called our Advanced Computer Science MSc. But we have 2 others. One is just called Computer Science, and the other one is called Cybersecurity. Both of those you don't have to have a computer science background in order to do them. So you will learn programming basically from scratch, and you will also learn all the sorts of topics that we've just been talking about are there as options or are there as compulsory topics, but it's at a higher level in that it's a master's, but it starts you from the beginning of learning computing, and we get a lot of people with really wide range of backgrounds on those courses.
Brilliant. Thank you very much, Helen, and thank you for answering all of our questions. I will hand back to Anna to just sign us out of the session. Thank you.
Thank you.
Thank you, Grace, and thank you, Helen, for a really interesting talk. And just to let everyone know that Helen's going to be doing another session on that similar theme, is it, Helen, as part of the university's diversity festival?
It's not me. No, sorry, it's not me. It's Sue Black that's doing the talk.
Brilliant. So if people want to find out more, I'll just pop the link there in the chat as well. So definitely head to that. Equally, if you'd like to see any more of our kitchen session series, we've got loads of different talks available to watch on demand on a host of different subjects, and more to come as well. So do head to our website if you're interested. But thank you very much to Helen, and thank you and goodbye.
Okay, thank you.